All right, today we're going to take a look at polynomial and rational inequalities. I know we haven't actually talked much about rational equations. We've talked some about the equations. We haven't talked about functions and what to do with graphs or anything. But the way in which you solve rational inequalities is exactly the way in which you solve polynomial inequalities. So these still make sense to do at the same time. So we're going to take a look at these today. This is our last section of new material before our exam. And we're just going to jump in with flat out examples. You guys have looked at solving these before for equations. And now we've looked at solving inequalities when they were linear. And this is sort of a combination of those two ideas. So to start with, all of my directions are going to say the same thing here. So if you just write this direction header down one time, you'll be good to go. It's just copy and paste it to every slide. So we're going to graph the solution on a number line, and we're going to write the answer in interval notation. And when you get your homework, please don't assume that that's the directions for every question. It is not. Some of them ask you to do one of these things or the other, and some ask you to do both. So I decided it would just be extra practice for us to do both on all of them. Sound good? Yeah, it's good stuff. So we're starting with one that's in factored form. Okay? So always our goal will be factored form on one side and 0 on the other side. So this is where we want to get every inequality to. Okay, it's just starting here on this problem. And we're going to do much like we did on the equations you've been working on in the last two sections, where we set each factor equal to 0 and solve. Okay? So we start this process by taking each of these factors, set equal to 0, and solve. And if you need to see the set equal to 0 like I wrote in, show it if it makes it feel more comfortable. If not, and you just jump from here to here, I'm okay with that too. Some of us just like to see more details than others. This is certainly appropriate if you jump to that spot. Okay. So the next thing you're going to do, whether it asks you to graph the inequality or not, is you're going to draw a number line. Okay? Because your number line is going to help us to determine the solution set, even if we don't need the solution set drawn at the end. So just like before, we want to make sure on our number line we put the numbers in the right order. And I really don't care much about the scale. I just need there to be space between them. Everybody good with that? Okay. Then what I do is I literally test a value in each area. So you get a pick. So somebody pick a number that it comes before -1. -2. All right. And what we're going to do is we're going to plug -2 into this inequality. And what I want to know, really, is do I get a positive or a negative? That's really all I care about. I don't really even care what the number is. I just need to know, is it positive or negative? So if I plug in -2, I'll write my work up here. So I have -2 plus 1 times -2 minus 5. -2 plus 1, is that positive or negative? It's negative. How about -2 minus 5, positive or negative? Negative. And what happens when you multiply a negative times a negative? You get a positive. So do you see what I mean about not caring about the values? Okay? And because we only care about the signs, that's why it doesn't matter if I picked -2 and Preston picked -3 and Jonah picked -7. We'd always get positives. Okay? So on my number line, all I'm going to do right here is put a plus sign for now. And then I need to pick a value between -1 and 5. What is the, I don't want to say best, but easiest maybe to pick? 0. If you have an option to pick 0, pick 0, okay? 0 is the friendliest to pick. So we're going to do the same thing on the side. And you don't have to show the scratch work I'm showing over here on the side, okay? We need to put in 0. So now I have 0 plus 1 and 0 minus 5. 0 plus 1, positive or negative? Positive. 0 minus 5. Negative. And what is a positive times a negative? Negative. So we've got a negative right here. Now I need to pick a number that is bigger than 5. 6. or whatever, but 6 will be great. 6 plus 1 and 6 minus 5. What is 6 plus 1, positive or negative? And 6 minus 5? Positive. So what happens when I multiply two positives? I get a positive. Okay. After we do a couple more examples, you're going to notice that a lot of times the signs alternate, positive, negative, positive, but they don't always. So please be careful and not just assuming that's going to work, because it doesn't always. But the question comes from this particular picture now is, what is my answer? And it's based on this sign. This sign, it says that it needs to be greater than or equal to 0. So do I want the positives or do I want the negatives? The positives. Greater than or equal to 0 means positive. So my answer is actually the positive parts of this graph. So if I'm actually asked to draw my number line, right, shade it in and graph it on number line, I'm almost done because I've done that already. The only thing I haven't done is included parentheses or brackets. Which one would I include for this one? Brackets. How come? Because it's greater than or equal to. Yeah. So at this point, if I'm only asked to graph the solution, I'm done. If I'm asked to do the inequality note or the interval notation, I need to translate that into intervals. So starting at the far left would start at negative infinity. And if I move along my number line, I stop at negative 1, whoops, with a bracket. And then I pick back up at 5 with a bracket and continue on to infinity. So that's what the interval notation would look like. And truth be told, if you're not asked to graph, I'd still recommend you do graph. It's a lot easier to write down the interval notation from a graph than any other way to do it. Okay? So literally, we're going to try like several more examples, and this is it. Every problem will look like this. Okay? Now, this problem doesn't exactly start at the same place, right? So I mentioned two things when we looked at the first example over here that were sort of what our goal was when we start working through the problem. Do you remember what I mentioned? I need to factor. I need things in factored form, and there's one other piece. I need everything on one side with 0 on the other side. Good job. Good listening. Okay, so on this one, neither of those things are currently in place. So I'm actually going to do both the things that you girls mentioned, but like in the flip order. I need to move the things on the same side first, which is what Megan mentioned. So the first thing I need to do is I need that 8 to be over here as a negative 8, and then it is less than 0. And then Karen mentioned factored form. So I need to factor x squared plus 2x minus 8. So how will that factor? X plus 4 and x minus 2. Is that okay for everyone? At this point, it's exactly the same problem I had before, right? Factored form on one side, 0 on the other side. Yes, I realize the numbers are different, the sign is different, and all that stuff, but the differences are simply in how it displays itself later. The process is the same. So we're going to set each part equal to 0. So x is equal to negative 4 and positive 2. Is everyone good with that? What did I do next? Yeah, I put them on a number line, or I graphed them. You got it. So here's my number line. Negative 4 is before 2, so we'll put them in like this. Now what? Choose numbers. Sarah, you want to choose the first number for me? Negative 5. All right, so Sarah has chosen negative 5 for us. So I'll use some scratch work. You have a couple options. You can put it in right here if you want. I mean, that's okay. I think it's still easier to put it in factored form because then I only have to worry about positives and negatives, and I don't actually have to make the calculations. So that's my favorite place to put it in. So if I'm choosing to put it into x plus 4, x minus 2, then I would have negative 5 plus 4 and negative 5 minus 2. So negative 5 plus 4, positive or negative? Negative. And negative 5 minus 2? Negative. And a negative times a negative is a positive. So this is positive. What number would we like to pick between negative 4 and 2? 0 is friendly. Okay, so I have 0 plus 4 and 0 minus 2. What are the signs of each of those two factors? Positive and negative, which gives me a negative. So I've got a negative in between. How about choosing a number after 2? 3. All right, so now I have 3 plus 4, and I have 3 minus 2. What signs do I get from each of those factors? Positives. And a positive times a positive is a positive. Okay, so I'm going to pause right here. If you do not understand how I'm getting my negatives and my positives and my number line down there, please ask me now. Sarah?
Okay, I understand how we get them on our number line, but like, how does that determine like the next word?
The where we shade?
Yeah.
Okay, we'll get to that one in a question in a second. Any questions about where the negatives and the positives are coming from? Because I'm moving very quickly and I want to make sure we're good. Okay, Sarah, to answer your question, what we do is we look at the sign right here. Okay, this says that it's less than 0. So does less than 0 mean negative, or does less than 0 mean positive? It means negative. So that's how we decide. This one says less than 0 negative, so the answer would be the negatives on our graph. Yes, Preston?
Oh, no, I was thinking about it, sorry.
That's okay. And then after that, we have to decide on parentheses or brackets.
Well, that's
Parentheses, because there's not an equal to, right? So this would look like this on a number line, shaded in between. And then my interval notation corresponding to that would be negative 4, 2. Is that all right for everyone? Okay, this one's already in factored form, which is nice, but I want to show you something that's different. Do you see how there's a square on this one? Yeah, when I have a square or a cube or a power 4, that's going to be the cases where I'm probably not going to have it alternate positives and negatives, just to give you a heads up. Okay, those are the ones. So we're going to set each factor equal to 0. None of that changes. So x is negative 2 and 7. Okay, so that's the same. The number line setup is also the same. And choosing values between the intervals is the same. Somebody choose me a number before negative 2. Negative 3. Okay, and let's plug in negative 3. So I have negative 3 plus 2 times negative 3 minus 7 squared. All right, and then I'm deciding to have positives or negatives. So negative 3 plus 2, is that positive or negative? It's negative. Now, negative 3 minus 7 would be negative, but then I'm squaring it, so I get a positive. So that square here really changes things, doesn't it? Really does. It means that no matter what I put in there, it's going to be positive in that second term, or that second factor set. Then I've got a negative and a positive, which makes it a negative. So I've got a negative before negative 2. We'll choose that 0, of course, between negative 2 and 7. So I have 0 plus 2 and 0 minus 7 squared. 0 plus 2 is positive. And then 0 minus 7 and then squared is also positive. So this is positive. Now, normally, right, we would expect the negative would come next. They tend to alternate. But on this one, they're not going to. So picking a number bigger than 7, I'll just choose 8. I would have 8 plus 2 times 8 minus 7 squared. So 8 plus 2 would be positive. And then 8 minus 7 and squared would also be positive. Again, squaring makes it all positive, and that one was already positive, so I end up with a positive here. Okay, so everybody sees that they didn't alternate, right? Which values do I want? Do I want the positives or do I want the negative? I want the positives because this says greater than or equal to 0, right? That means positive. So these are my values. And as I'm looking at that, because it says less, and actually if you have to be a little bit careful, technically it's this set, right? And I have to be careful about what happens at 7 because this says I can equal 7, it doesn't matter, but if this said like there was not an equal sign on the bottom of that, I would have to put parentheses. So here, if I were trying to do brackets because I've got less than or, greater than or equal to, technically it looks like this. Whoops, sorry. So when you see this bracket open, bracket close, there's no reason to bracket it. Are you with me? I mean, if you did, it wouldn't be wrong. It would just be awkward. It wouldn't make sense to do it that way. So this really, the interval is just -2 to infinity. All right, let's try another one. There's something about this one that's slightly different than the other ones we've done. Can anybody see what it is? Yeah, it's x squared minus 9 instead of just like x minus 9, right? The reality is that this factors further. So it's mostly factored here, but not all the way. So we need to be careful and capture that feature. How does x squared minus 9 factor? Right, x plus 3 and x minus 3. So we need to make sure that we've gotten things down into their linear factors, right? That one was a quadratic factor before we continue. And then we set each piece equal to 0. So at this point, I'm just going to jump to the values. This would be x equals -3. If this was set equal to 0, I'd get x equals 3. This one set equal to 0 is x equals 1. And this one is x equals -1. Are you guys okay with those values? Okay. 4 numbers on my number line. Holy majoli. Okay, look at this. And they're all kind of close together, even right there in the middle. I don't need to draw them that way, though, right? Draw them spread out. So -3, -1, 1, 3. What would you like to test first over here? -4. And then in the middle here, how about a -2? 0. And then I can actually do the symmetric values over here and do 2 and 4. There are 5 numbers because there are 5 intervals to test. And let's be honest, do we expect them to alternate? We expect they probably will, right? Because I don't have any squaring going on like that one. This one over here had that square at the end that caused the alternating to mess up. Okay? So I expect that there will be alternating values. So we're going to start out by plugging in -4. And again, you could use the top one if you want, but I kind of like putting them in here myself a little bit better because then I can look at the positives and the negatives. It wouldn't be bad to put in the first one, I suppose. But so I have -4 plus 3, -4 minus 3, 1 minus -4, and -4 plus 1. Okay, signs. I've got 4 signs. What's the first sign? Negative. The second sign? Negative. The third sign. What is 1 minus -4? It's 1 plus 4, right? So that one's positive. And how about -4 plus 1? Negative. So there are 3 negatives and 1 positive, and I multiply them together, what do I get? This one is negative. So I have a negative starting out on my number line. We'll test -2 next. -2 plus 3. -2 minus 3. 1 minus -2. And -2 plus 1. First one's positive. Negative. What's 1 minus -2? Positive 3. Yeah, so it's positive again. And then -2 and 1 would plus 1 would be negative. So how many negatives do I get? 2. So what's a negative times a negative? Positive. So this one is a positive, which is kind of what we were thinking was going to happen. Test 0. 0 plus 3, 0 minus 3, 1 minus 0, 0 plus 1. What are my signs? Positive. Negative. Positive. And positive. For a total of, what happened on that one? Negative. I think there's negative, right? Because I've got only one negative here now. Is everybody good with that? So that one's just a negative. I have all my features there. So this one's a negative. Let's see, I need a number 2. 2 plus 3, 2 minus 3, 1 minus 2, 2 plus 1. Okay, I think I got them on there. Is that okay? What's 2 plus 3? Positive or negative? Okay, I'm going to go with positive. How about the 2 minus 3? That's negative. Good. 1 minus 2? Negative. And 2 plus 1? Positive. So I'm back to having 2 negatives, which gives me a positive. And then I have the number 4. So 4 plus 3, 4 minus 3, 4 minus, no, sorry, that was, I'm sorry. It's 1 minus 4. 1 minus 4, and then 4 plus 1. Okay, so I have positive, negative, negative, positive. Did I get those right? Oh, that one was a positive, sorry. Positive, positive, negative, positive. Which is a what? A negative. Which do I want? The positives or the negatives? The negatives. Here, here, and here. Because this says less than or equal, I'm sorry, it says less than, excuse me, 0. So I just want the negatives. All right, so my interval will look like negative infinity to negative 3. And it says less than, so I've got parentheses here on everything. I have negative 1 to 1, and then I have 3 to infinity. This one is our last example of a quadratic or a polynomial one. So just like on the other ones, I need them all on the same side. So we'll start by moving the 7x squared, and I'm going to put it in order as I go. So x cubed minus 7x squared plus 10x, and it's greater than 0. So to start with, they all have something in common. What do they have? An x. So if I factor out an x, I have x squared minus 7x plus 10. And this one will factor as x minus 2 and x minus 5. Everybody good with that? Fabulous. Okay, so each piece of this now is set equal to 0. So I've got x equals 0 from the first piece, 2 from the second piece, and 5 from the third piece. So on my number line, I have 0, 2, and 5. So I don't get to test the number 0 now because it's part of an endpoint of an interval. So I need to test something negative. How about -1? Between 0 and 1, we would test the number 1 at 1. Between 2 and 5, we would test 3. And after 5, we would test maybe 6. All right, we get a choice of where to plug it in. Again, I kind of like this piece best because it's in factored form. So I can test this and I plug a -1 in for x, -1, and then -1 minus 2, and -1 minus 5. So the first one's, of course, negative. Second one's negative, and the third one's negative. 3 multiplications that are all negative give me a negative. Okay, we'll do the number 1. So if I plug the number 1 in, well, the first one's now positive. What's 1 minus 2? Negative. And 1 minus 5? Negative. So positive, negative, negative is positive. 3. So 3 times, and then 3 minus 2, and 3 minus 5. So 3 is positive. 3 minus 2, positive or negative? Positive. And 3 minus 5? Negative. So positive, positive, negative is negative. The last one is 6. Okay, so 6 is positive. 6 minus 2 is positive, and 6 minus 5 is positive. So there's 3 positives on this one, which gives me a positive. Do I want the positives or do I want the negatives? I want the positives. This is greater than 0. So on my number line, the positives are here and here. Am I using parentheses or brackets? Parentheses to open and close each set. So, kind of running out of space. Let me do this. So I have 0 to 2 and 5 to infinity. All right, so here's what I'm going to do. I'm going to stop the video here. I have 2 more questions to do, and I'm going to record it as a separate video. Literally, it's going to take me 5 minutes, and I'll do it right when I get back to my office, okay? So I'll post both of these over the lunch hour, so you'll have access to the other one to be able to finish the homework and get that turned in.